I got v as a function of u only, no x, no y, no z. Okay, now I go to dr. dr, I know it's dxi, dy, j, dz. So I will find the x as a function of u. X here is a 3u, so it will be 3 du. Here y is 2u squared, so dy it will be 4u du, as you can see here. And the same thing here, 3u to the power 3, it will be 3u to the power 2 du. So dr become function of u, no more x, y, z. Now what is left? The point A and B. A is 0x, 0y, 0z. So I will substitute here 0, you see here, x it will be 0 equal 3u. 0 equal 2u squared. 0. These three the equations are correct when u equal 0. If you substitute here by 0, 0 equals 0, 0, 0 equals 0, 0, 0 equals 0. Now for B, now I will substitute x by 3. So here it will be 3 equal 3u. So this means that u should be 1. So 3 equal 3, as you can see here. Same thing for y, it will be 2, z equal 1. All of them will give u equal 1. Now you can see here I converted v, dr, a, b as a function of u. Now next I will substitute and do the math. Have a look. This is my formula. I change b and a. It become a is u at u happened at u 0 and b happened at u equal 1. V I got it as a function of u. dr I got it as a function of u. Now this is scalar multiplied by vector, so I multiply by each one of them, number with numbers, use with use, and integrate each one of them with respect to du, as you can see here. Right? Do the integration. As example here, u to the power 8 will be u to the power 9 over 9. Here u to the power 9 will be u to the power 10 over 10. Here to the power u to the power 10 will be u to the power 11 over 11, as you can see here. Now next is to substitute between 0 and 1 and simplify. We get a vector. So line integral for this curve, when it is scalar, it gives vector. Now this is exercise for you. I just change here the function and the values for x, y, z, and the point here, the point B. Otherwise, it's the same example, previous example. What I want you to is to know how you follow the procedure to find this answer. This is the final answer. If you reach this one, it means you know the procedure and you have the skill. The next point is when vector field, f line integral. Okay? Now in the previous one, we have scalar and we did the line integral. Now we have vector. We have many applications. Example, speed and direction of a moving fluid through space, or the strength and direction of some forces such as magnetic or gravitational force, and so on. It have many applications. Now what is the rule? The rule is, as you can see here, we have f vector, dr vector, and there is dot product between them. So what do you expect? In dot product we have a scalar or vector? Okay, you will say it's scalar. Great. That's correct. Let's see how we find it. Integration along curve f, c, for vector f dr will give at the end scalar. No I, no j, no k. Let's see this example. Next example will clarify everything. I ask you to find integration along curve c for f as a vector dr. You remember directly this is vector line integral, field line integral. I gave you A, I gave you B, and I told you that the curve have x equal with respect to time, y equal with respect to time, and z equal with respect to time. This is f is given to you as a function of x, y, z. See, the procedure is the same. We convert everything as a function of t. Okay? Example, have a look. This is x squared. It will be 4t squared. This is y. It will 2t squared. You see, I'm using brackets. to make sure there is no mix between items, no mistakes, and I simplify, I got the vector. The same thing, dr function of x, y, z. I find here, this is x, dx will be 4 dt, dy will be 4 t dt, and so on. I substitute it here. Now there is no more x, y, z. Now I come to substitute to find f dot dr, which is at the end scalar. Now this is f from the previous slide, and this is dr from the previous slide. Now this is dot product, so this element supposed to be multiplied by this element, I elements, j elements, and k element. You see here, these are the elements. Simplify more and take dr as a common. We are here. We prepare everything now. Just one more issue is a and b. A, when x, y, z is 0, 0, we substitute here as example 0 equal 4t. I directly know that t is supposed to be 0. 4, x equal 4, so here I will say 4 equal 4t, then t is supposed to be 1. You see? Now I go to the formula. This is the formula. Integration from a to b f dr. I already got this part for f dr from the previous slide. Rather than ab, it will be t equal 0, t equal 1. Do the integration. This one, it will be t to the power 5 over 5. This one, t to the power 6 over 6. T to the power 8 over 8. And then substitute from 0 to 1 and simplify. What we got? Scalar. We started from vector, we finished with scalar. This is exercise. I just changed the equation, the vector itself, elements. I changed the value for b, and I asked to follow the same procedure in this example, the previous example, to find this answer. If you find this answer, then this means that you have the skills. Last part is Green theorem. Green theorem. Now, until now, scalar line integral and vector line integral, we've been talking about curve, open curve. Now, what if the curve is closed curve, not open curve? Then we have to go for Green theorem. Green theorem simply is to use line integral, but for a closed curve. And to find this, what we use double integral. Have a look at the formula, at the theorem formula. This integration, you see here, integration this way, there is circle and there is c. To say that this c, this curve, is a closed curve. It's not normal curve, it's a closed curve. F dx plus g dy. Okay, how we find it? Double integration. Now partial g, this g, with respect to partial x, minus partial f, this is f, with respect to partial y. Integrate with respect to dx dy. Very easy and direct and straightforward. With example, it will be very easy and clear. He told me to evaluate the line integral over a triangular curve with the vertices 0, 0, 1, 0, 1, 1, oriented in the given order. And he gave you already the formula here. You see this circle? This circle means that the C curve is closed curve. And this y represent f, and this j, minus j, sorry, represent, this minus x represent j. Because I have the formula. I write the formula and then I start substituting. Partial g over partial x, this is g minus x, you see here. And partial f, what is f? Y over partial y. This will give minus 1, this will give minus 1, so minus 2, as you can see here. I will take it outside, minus 2. Now integrate with respect to dy and substitute the internal one. Substitute from 0 to 1 to give 1. We are here. Integrate with respect to dx, it will be x. Substitute for 1 and 0, 1 minus 0, 1, it will be 1. So at the end, I got minus 2. You see here? So I did double integration. Just formula Write the formula and substitute. You will find the final answer as a value, no ijk, not a vector. Let me stop here. We will continue next session.